This is my presentation on the cost effectiveness of patient navigation, and this is my simplification of the study on the cost effectiveness of patient navigation in the Health Services Research Journal article from the course readings. So to configure the cost effectiveness analysis, we set willingness to pay $50,000 per quality adjusted life year. That's the dollar value of a year of life. I put cost in dollars and effectiveness in quality adjusted life years. I label them here in the numeric formatting section as usual. So I'll just sort of standard procedure to configure TreeAge to do a cost effectiveness analysis or an economic evaluation. Cost effectiveness analysis, one type of economic evaluation. So I always just label the first part choose. That blue square, that's called a decision node. That's where you choose between two options. In this case, we'll just add two of these red triangles coming off of that decision. So one's going to be for patient navigation is the top red triangle. The bottom triangle is for the comparison group of no patient navigation. So we're going to evaluate the cost effectiveness of patient navigation as compared to no patient navigation. This is an economic evaluation on the cost effectiveness of patient navigation. An economic evaluation, cost effectiveness is synonymous. So we're going to say that the cost effectiveness of patient navigation is a function of cost and the quality adjusted life year. So whether or not patient navigation is cost effective will depend on two variables. The first variable is cost. We set that equal to $45,000 in the default or base case scenario. And the second variable is quality adjusted life years. We set that equal to 1 in the default base case scenario. So by building out this tree here, we're just going to evaluate the cost effectiveness of patient navigation when the cost for the patient navigation program is equal to $45,000 and the patient navigation is associated with one additional quality adjusted life year. So one quality adjusted life year is the utility gain from spending that money on patient navigation. You put the cost and the effectiveness here, so those are no navigators like a placebo, minimal cost, minimal quality. You pay nothing, you get nothing. With no navigator, a navigator by comparison, I think might have some cost effectiveness above no navigation. So again, the first thing we do is we draw the supply curve, and we're asking whether or not it's cost effective to scale up the supply curve from no navigator, the red square, to navigator, the blue triangle. That's going to depend on the slope of the supply curve. So the slope of the supply curve, well, that's the incremental cost effectiveness ratio of navigator as compared to no navigator. So the ICER of navigator, it's $45,004.50 per quality adjusted life year. So you can see that ICER of $45,000 is less than the willingness to pay, which we said was $50,000. So it's going to scale up the supply curve from no navigator to a patient navigator, switch from no navigator to navigator, and choose patient navigator. So the result of the economic evaluation in this case would be that patient navigation is cost effective compared to no navigation. And given this data, given the numbers of the problem, that the policy analyst or the evaluator would recommend navigator, given that it costs $45,000 per quality adjusted life year. And that's just the base case scenario there. But remember, we're going to let the cost effectiveness depend on the cost and the quality. So we're going to undo that rollback. And instead of a single solution, we're going to have a range of solutions. So we're going to examine the tornado diagram. Now the tornado diagram measures, visualizes how much of an influence the different variables in the model have on the net monetary benefit and the ICER. So how much of an influence does the cost have on an ICER? How much of an influence does the quality have on an ICER? Which has the larger influence on the ICER, the cost or the quality? Which has a larger influence on the monetary benefits, the cost or the quality? And tornado diagram will give us a visual depiction of what the net monetary benefit is more sensitive to, what the ICER is more sensitive to. So first we look at the tornado diagram with the net monetary benefit. The black line at the beginning, that starts the net monetary benefit of no navigator. You can never do worse than no navigator. So even if navigation was wildly ineffective, you would still choose no navigator and get a net monetary benefit of 0. That's the black line on the left hand of the slide. That's the starting point for both of the bars. That's the net monetary benefit of no navigator. Expected value of 5,000, that's the net monetary benefit for patient navigation in the base case scenario. So if you go back to that ICER table earlier, you'll see the net monetary benefit of patient navigation is $5,000, given those baseline values we set of $45,000 for one quality adjusted life year. The third main point about this graph is that the net monetary benefit is more sensitive to the larger bar. The larger the bar, the bigger influence on the net monetary benefit. In this case, the dark green bar, that's the larger bar, that's quality, that has a larger influence. So in this example, quality has a larger influence on the net monetary benefit than cost, because the dark green bar for quality is larger influence on net monetary benefit. Light green bar for cost, smaller. Cost has a smaller influence on the net monetary benefit. We do the same thing with the tornado diagram for the ICER, the incremental cost effectiveness ratio. So that expected value of $45,004.50, that's the incremental cost effectiveness ratio of patient navigator compared to no navigator in that base case scenario that we solved earlier in the slides for rollback. What tornado does is it says, what is the ICER most sensitive to? Which of these two variables, cost or quality, has a larger influence on the ICER? The bigger the bar, the larger influence on the ICER. So the red bar is quality. Red bar is larger. Red bar has a larger influence on the ICER. The quality adjusted life year has a larger influence on the ICER. In this case, the blue bar is smaller. The bar for cost is smaller. The blue bar is cost. Cost has a smaller influence on the ICER. And it just ranks them. So it can have a lot more bars, and the largest bar is always the largest influence on the ICER or the net monetary benefit. The smallest bar is always the smallest influence on the net monetary benefit or the ICER.